I was
during football season would walk out of the library.
in graduate school. I would go till 2 o'clock in the morning and get up at 6 or so. All right. So Chelsea, you asked about chapter 1. So let's just start there. Basically, I'd say the only thing that you should know from chapter 1, I better be careful the way I word that, but the main thing is those 5 axioms. So just go ahead and memorize these. Prices do what? Number 1 is the one we've used the most, I think. Adjust. Prices adjust to achieve locational equilibrium. I'll just put them all in one spot. They're pretty well identified in your textbook, but we'll write them all up on the board here tonight. Number 2, self-reinforcing effects generate extreme Number 3, externalities. This one we'll use later on in the book, more so than we have. Externalities cause inefficiency. Number 4, production is subject to economies of scale. And number 5, competition, we've used this one quite a bit, generates economic profit equal to 0, or 0 economic profit.
In the long run? Or is that just
It would be more of a long run concept, yes.
All these different concepts.
Yeah, they are. Yeah.
Are these axioms from intermediate then? Are they
Kind of. I mean, they're conclusions. They're kind of general conclusions that we got from either principles class or intermediate class that are especially applicable to this class, like externalities causing inefficiency. You know, we learned about pollution, that sort of thing. Okay, and then Adam was asking about the test. So if you guys know these homework problems well, that you should do pretty well on the test. And then I will throw some sort of challenge question out to you that kind of pushes the envelope a little bit further.
Question, like, what's the last name of the president?
Well, it wouldn't be much of a challenge. No, not that.
That was a challenge question before.
That was the extra credit.
People
question.
got it wrong.
That's true.
how much is a pound of butter weigh?
Dude,
Yes, I know.
I missed that.
That might be on
Or
there.
you're like, what weighs more, a pound of
You
rice
missed
or
a pound of butter?
I missed a pound of butter.
You did.
I overthought it. I was like 18 ounces.
It happens. It does happen.
I couldn't catch myself out of a paper box.
Well, one of them was like, if a cheetah can run so many miles an hour, how much does
Does
a pound of butter weigh?
Yeah.
And Mitt Mom's put not enough information. Mitt Mom.
That makes sense. The most pissed I've ever been on the Rust test is whenever he put something on the lines of, what does this Disney character represent on the business ethics file? I was just like, are you?
Oh, it's like,
What was that?
I don't remember what the question was.
All right, let's stay on track here. Let's get Spatial knocked out. But my point is that if you work through these homework problems and you understand the homework problems, they're right in front of you. You got the answers. We worked through them. We've done them in class. You know, some of your test anxiety should go down a lot. If you feel like you can look at these problems and do it. I might change the numbers around a little bit so that you just didn't memorize the question, right? And then there might be a couple extra challenge.
Would you
type
provide
questions.
some
So
sort of,
challenge meaning something a little unique. So
like, will you be providing, I guess, some sort of, like, rock shell that we can work off of? Like, in some of the in-class examples that you've given us like the graphs already there or something like that?
I'm going to give you a modified version of the homework problems.
So it's basically like
If you can't read between the lines here for a large part of the test.
No, I know.
And then I'm not going to comment on what the rest of the test is. That'll be your little bit of,
I just
you
didn't
need to
know.
know your stuff, yeah.
Okay.
Okay?
That's a question that I already just threw.
So that's your benefit. That's know these problems, be able to work through these problems, and you guys will do just So we'll kind of, yeah, don't read, don't do the problems, C or lower. Do all the problems, understand them pretty well, be able to work through them, probably a solid B for sure. Be able to get some of the challenge questions that are a little bit tougher, there's your A. Okay?
Is that the review?
All right. So, no, that's not the review. We got more to go.
Can I ask?
Yes?
Do you know how they're spaced out? Are they pretty evenly in each chapter? Or
Yeah, I'll probably spread. I haven't written the test yet, but I plan to spread it out pretty evenly among the chapters, yeah. Except for number so 2, the place for the homework problems are.
Oh,
And you said that's what our time obviously that's
Yeah. Oh, yeah. Hopefully, I wouldn't. If you haven't done a darn thing the whole semester, I wouldn't recommend starting reading tonight. You probably ought to start hitting some problems. From a practical standpoint, that would probably be better use of your time. But ideally, yes, the reading supports everything. It kind of fills in the gaps, right? I mean, if you look at the problem and you're like, oh, what the heck, and then you read, then it starts to fill in the gaps. So hopefully we'll fill in more gaps tonight too. All right. I was thinking, unless you guys want to do it differently, I've got a few things, kind of some high points of the chapters, just kind of a quick little summary. I took a little time and just jotted some notes down, so that kind of works through the material. So chapter 2, and then maybe we can hit some of the problems that we had too. So, but let's start off with kind of an overview of chapter 2. We hit the gains from trade, first of all. Production possibilities frontier, showing that 2 people can be made better off, 2 countries, 2 whatever, 2 people trading. And then we expanded that into our first variation that's relevant for this class called the factory city. And we introduced economies of scale, and we set the stage for moving away from this self-sufficient production, where we just kind of do it ourselves. If we can move away out of the household production model and into a factory, you know, what does that get us? What does it get us? It gets us a martini glass. So the martini glass model kind of came out of that. And the stem, we draw a little picture, remember, it kind of looks like this. We had our cost. The height of the stem was the cost. So the stem equals the actual cost of the good at the factory. And the edges of the glass, the sides of the glass, represented the travel cost of the consumer. So some sort of expense, which then changed their net cost, depending on how far they lived from the product. All right, so these 2 things together ended up generating what we called the net price to the consumer between the stem and the edges. Any martini glass questions? Kind of a quick overview, but as things come up, this is meant to be just kind of open dialogue. So.
the slope of the edges, isn't that usually equal to some?
Yep, the slope was each travel distance, and so it was like 1 mile, 2 miles, and so each increment over raised the cost. So it was the travel cost on a cost per mile. Yep.
Of like a loaf of bread, like for example.
Yep. So that's what that slope relationship. As you go over 1 mile away, it costs you a little bit in travel cost. John?
What was the stem? Wasn't it labor cost plus opportunity cost or production cost or whatever?
It was the cost of the product at the factory. So it's what's taking all those things into account, or whatever went into the production process. So at the factory, we were able to do it lower than what we could do at. So this line up here, the top of the martini glass, was the household production.
Right.
And so because of economies of scale, the factory was able to produce it at a lower cost. But then we've got this travel thing put in there.
Because in the, sorry, I don't mean to interrupt. The problem that we did in the book, the stem was 4/12, and so then you did something that made it add it to 1 or whatever. So like both sides.
Yeah, the way those
Distance-wise.
numbers came out, it was 1, so it was 12/12 was the household production cost. That's just the way that particular problem worked out. And so we had 8 miles was the market area. That's what defined our market area, is because consumers would be indifferent between making it themselves or buying it from a factory and living 8 miles away. That's where they were indifferent, because the cost to them would still be 12/12. 8/12 worth of travel cost and 4/12 worth of actual cost of the product. Okay, anything else on the martini glass?
Do we think about the like upside down martini glass at all?
We can get into that on the problems. Well, actually, it kind of comes into the next problem. So we can get into that. There is a problem like that with the upside down.
You may have already said this, but just really quick, how did you determine where the factory city will rise up next to that one? Does that make sense, like how many miles away?
It was with the
Where that self-sufficiency, so then there'd be another one that would start
Got it,
here.
okay.
Yeah. Okay, so the processing city was the next one that Michael was kind of referring to, or it's very similar. So with the processing city, and there's a different problem that phrases it, or that words it in the form of a consumer, but
I think I'm thinking about the concerts one.
right. We can come back to that particular problem, but you're right. It's the same thing as what the processing city is. So the processing city is, we had the example was a beet producer. And now we're thinking of dollars over here, and the closer that you are to the processor with your product, if you're the farmer getting beets processed, then the higher price you're going to get. If the market price of beets is $40, you're going to get $40. But if your plant is a mile away from the processor or 2 miles away, then you're going to have travel expense going to the processing plant, which then lowers your net price. And so that kind of gives, it's a similar concept here. All we've done is we've turned it into the price that the producer's getting. They're kind of paying that travel cost. Here, the consumer's paying that travel cost, so it's raising their effective price of the product. Here, the producer is paying the travel expense, which gives you the upside down martini glass. In the problem that Michael is bringing up, we have the consumer that is getting some disutility by having to travel for the live concert as opposed to the recorded music.
So that's the same shape.
Same shape.
It's just like.
Yeah. Yeah. It'd be utility instead of dollars. Right. Right. So we use that conversion of dollars and utility if it was 1-to-1. Was an assumption we made at some point. Okay, so that was the processing city, kind of upside down but very closely related. And then the last one in this chapter was the innovation city. And here we've got knowledge spills and cost of living competing with each other. So we want to be together in a city because I like feeding off of other smart people and talking with them and communicating with them. So that was the knowledge spill. But when we live together, we tend to have congestion and other things that drive up the cost of living. And so this was the one where we get the payoff, the net payoff function. So workers enter the city until the marginal payoff kind of the net benefit. The marginal payoff equals the self-sufficient setup. Eventually, the cost of living overwhelms the knowledge benefits, and so the city at the margin starts to become, a person becomes indifferent between staying in all by themselves or entering the city.
And that formula is different every time, right?
Yeah, there's no, that's going to be totally dependent upon how these variables work. They gave you that formula in that one problem we did, but that was just.
How those be demonstrated in the exam? Aren't they variables like X? They're not X and Y, are they?
Remember
It was the.
leaf graph, kind of looks like a leaf. I don't know.
Well, we're pretty much done with chapter 2. Why don't we jump into the problems if you want to?
right here. Yeah, okay, I see what you're saying.
So if you want to look at it,
Okay.
the formula you're talking about, wasn't that question 10 or something like that?
Yeah.
That's the beats one.
Let's see, what are we in? We're in chapter 3?
Page 36 is the problem.
No, I think you're thinking about 12.
Oh, I was thinking about, 12, yeah. The last one. That was
Okay.
towards the end.
Which made no sense unless you had some sort of quadratic equation already.
You couldn't solve for n, is what it was asking for. Like, how many workers are going to enter the city is ultimately what that question was asking. And so it said the payoff is dependent upon the number of people in the city. And that function is going to be graphically this little humpy function. And they've got it approximated by this 2 plus n to the half minus n over 10. And you can't solve this for n. So even though we know that the self-sufficient wage is 4, so this statement here, workers are going to enter the city until the marginal payoff equals the self-sufficient wage. The self-sufficient wage is $4. And so if we set this sucker equal to 4 and solve for n, that would tell you how many workers are going to go into the city. But the problem is you can't solve that for n. And that's what we did in class. You got to do a little. You got to do a little trial and error on figuring out what n would be.
So that's a quadratic?
Well, it's just
It's nonlinear.
Well, you can make it into a quadratic equation basically by subtracting to adding plus 10.
So you
It's
got
not
that.
linear problem.
You got the two constants. I'm not going to have you do this on the test, so let's not waste a lot of time. But you got the two constants. Put those together, and then you've got n 1/10 of n to the 1 power and n to the half power. And so then you can do. You could, in theory, solve it or plug it into a calculator or whatever.
So the main takeaway is set them equal to each other in order to figure out the equilibrium self-sufficient population.
So all of you guys got your books, right?
Yeah.
So if you turn to, so that I don't have to
the answer
put
is
down.
like 51.
So yeah, this figure 2.4, that gives you the picture. So that bottom graph, this little formula is approximating that bottom graph. N is the horizontal axis. So as n goes up, the payoffs go up for a while and then they go down. And then if you plug in a n equals 2 and an n equals 3, you'll see that happen with that formula.
So does the idea, I guess, no, never mind. Thinking of like the bigger cities or smaller cities, you can always get bigger, but bigger cities.
That's next chapter.
Yeah.
Yep. But this kind of helps build that story, I think. Okay. Let's see. Any other questions? I think there was a question on 2. Maybe that was 12. 2.9. Somebody asked about. Oh, and we did kind of talk about that. 2.9 was the performance city with the recording.
Which is the upside down.
Yep, so that was the upside down. So since somebody brought it up, let me go a little bit more thoroughly here. So consider a region where households produce and consume musical performances. They're either live or recorded. And after accounting for price, the utility from a live performance is 3 times the amount of the utility of recorded music. There are scale economies, which are provided at the performance at the center of the region. So using figure 2.1 as inspiration, depict graphically the method for determining the market area. So with that, we've got the utility with a live performance. You got to go to that particular space to get it, and you get 100 units of satisfaction. And a recorded performance gives you how much according to these numbers? I'm making up numbers, but roughly
It's 3 times the utility.
33, right? So 33 would be down here. So there's your recorded utility. Kind of like our martini glass, it's self-sufficient versus with the factory. But now we've got these 2 options, one being recorded music, one being live. The problem is we got to travel to it. So if we live a mile away, we don't get 100 units of satisfaction, we get a little less. If we live 2 miles away, we get a little less, and so we get that going down.
So there, the slope is like the utility used per mile.
Yes. And we're not given that information.
It doesn't say.
Yeah, right. So we're not given that information, but if we were, we could have said some sort of disutility that we get from mileage. Okay. I think that was it for chapter 2, unless you guys see anything else of other problems there. All right, actually the appendix. We had weight gaining and weight losing, and then we had the median location principle. So those were the main takeaways there. And remember, we used the median location principle later on as well. So chapter 2, appendix, weight losing firm minimizes cost. And I'm going to run out of my little whiteboard already. I should have started a little more to the left. Weight losing firm minimizes costs. If they're losing weight as they produce, is it better to be at the input source or the output source? Input. So weight losing firm minimizes cost at the input source. And the weight gainer, the weight gaining firm, if transportation is important of the output, they're going to minimize cost at the output market. Remember that these are location decisions. So we're going to minimize cost by locating our firm at the output market. We're going to minimize cost by locating our firm near the trees or where the timber's cut or whatever, for a weight gainer or weight loser. All right, and then the median location principle. Costs are minimized where travel is split into 2 equal halves. Even when the distance, remember that picture, you guys can look in your book, even when we had one location way over here and a bunch of locations here, the median was the ideal location, because we were still servicing this guy at least one trip. That was part of the assumptions of it, is that the number of trips, we were going to go an equal number of trips to everybody, and so the median was the best spot.
But there was like 9 over here.
Yes.
And like 2 or 3, and so like it didn't matter how far you had to travel to that one. It was the median of how many were like.
It's on page 42.
Correct.
Okay.
Yep. Yep, you're right.
Bottom. Page 42 at the bottom.
So if we've got the travel here in terms of consumers, if we've got 9 consumers here or whatever the number is, then that's going to change your middle spot potentially. Yes. Okay. Chapter 3. We got into the utility business. Oh no, that's 4. Never mind. Chapter 3. That's right. We got the agglomeration. So we've got agglomeration economies, kind of our big word for the whole course. And we broke that into 2 pieces. One, localization, and the other, urbanization. Both of these make up agglomeration economies. Localization was inter-industry, so industries that are similar with each other. Urbanization is kind of across industries. So we had, the whole chapter kind of went through these 4 sources. So 4 sources of why that occurs. 1, sharing intermediate inputs.
Does the book ever define urbanization or localization economies, or is it just assume that they're already interested in what they have?
At the very beginning of the chapter, I think they talk about it.
Like localization is the one where like firms within industry come together, and then urbanization is like across industry.
Right. And I just thought the page 45 in the middle. So the forces that act on a single industry together are called localization economies. And when agglomeration economies cross industry boundaries, they are called urbanization economies. Both of those things, both of those concepts come from potentially both of these, because this can, sharing intermediate inputs could go across industries or it could be within industries. So we had that dressmaker example, one industry, but we might have 2 types of firms that have highly skilled labor that are really different industries. So those 2 concepts can work, or these forces act on both of those things. So with the intermediate inputs, the model that we looked at is we have some cost savings. So some cost savings due to clustering together, and some increases in cost. And these 2 things were competing with each other again. The example we had was the prop cost in LA. So the cost of renting props went down as filmmakers clustered together in one location in Hollywood. Then it was cheaper for them to rent props for their stage sets. But by clustering together, there was an increase in labor costs. So the labor costs might have went up on them. was what was used in that example. So you got these two things competing with each other, and that created that profit gap. So creates a profit gap between cluster and solo. Locating all by yourself or clustering together. If the increase in costs eventually overtakes the decrease in cost from the cluster, then entry stops. And I think we had one problem. So let's kind of work through the 4, and then we'll go to the problems. Let's see, number 2, labor pooling.
What about self-reinforcing effects of conservation clusters? Is that one?
That's not one of these effects, no. That, I mean, that's tied into axiom 2, but it's not one of the 4 forces. It's part of this.
Okay.
It's part of what drives this.
The book just has it.
Yeah, they had a bold-faced heading on it, but yeah, it's not one of the 4. So labor pooling, the mobility of labor and the volatility of demand allow for a stable wage. So there was 2 things going on. If labor's able to move from firm to firm, this was this model where we had the 2, whoops, I didn't put this one. High demand, low demand, and a fixed supply. Versus the elastic supply and the 2 demand curves. So the graph looked something like this. This was actually real little. Just as a quick little reference, you guys can look in the book.
That one's like in isolation.
Yeah, yeah. This was in isolation. This is in the cluster. So that just gives you a quick little visual from the book, the model that we looked at. We did one problem from there too. Number 3, labor matching. So our conclusion from that little, the little dial thing, if we added more workers, we got better match of skills. There was kind of a smaller gap. We went from an 1/8 to a 1/12 or whatever is kind of how they did that with that table. More workers led to less of a skills gap And that led to lower training costs. And ultimately, a higher net wage. There was less training cost, higher net wage. So it ended up being kind of a better situation for employees. And number 4 would be the knowledge spills. So knowledge spills were the extra, productivity or thinking that we get from having people close together, the talking, the communication, stuff like that. Those are the things that are the forces that are giving us these agglomeration economies. All right, so chapter 3. Let's take a look at questions. Let's see, I had number 3 and number 7. So let's start with those. Okay, so number 3 was that one we did in class. And the thing that was a little odd with that one compared to what we did in class was the setup of it. I'll just put this thing out. This was similar to doing a change in consumer surplus on the benefits. So if we look at a market with supply and demand, and consumer surplus is that little triangle, and we open up for trade and prices drop, then consumer surplus got bigger, and consumers benefited that area. That's what we ended up using in this problem. We didn't know what this endpoint was, so we couldn't actually calculate it like what we did in the book problem. And so we had to kind of figure out that extra area. So here's the problem again. We've got the table. We're analyzing an isolated firm versus a cluster, high demand, low demand, and what we can pay our workers. And we have a workforce of 50. That is the inelastic version if we're in isolation. So we had a little 50 down here. If we were drawing a picture that was similar to what was in the book, there'd be a 50 at the supply, and then a high demand, low demand, and then a wage of 40 and a wage of 20. And then with the cluster, supply becomes perfectly elastic, and it's at 30. When times are tough, then firms go work for the person that's doing well, so they get laid off with their current job, but they just go work for somebody else. And so that was the comment I made on the board about the mobility of labor. They can kind of transfer around. For this problem, we're not in real class, so I guess.
That so counts. We need it.
So figure 3.3 was part A, that you could change the numbers around, except we didn't know these endpoints. So during good times, the benefit of being in a cluster as opposed to being isolated would be computed as what? And so we're holding constant the good times demand. That's this one. And because the labor force is different, we have 60 workers working for $30 in the cluster. We got 50 workers working for 40 in isolation. And so that's where we pick up that triangle, and that's what that formula does, is just kind of gives us the area of the shaded area. Let me pause there. Questions?
10 times, where are you getting the 10? 10 times 50? Are you subtracting the workforce?
This
the wages.
rectangle right here. So 40 minus 30 is 10
Got it.
and 50. So I'm just kind of adding up the highlighted areas.
So, truthfully, part B, we're not talking about what's the total, I guess, consumer surplus or anything like that. We're just talking about the benefit on top of what already you would be receiving as an isolated.
The benefit under the conditions of a high demand situation of one versus the other. Yep.
But on this one, are you basically like are you almost basically combining the cluster and the isolated site?
Because it's still the same. Whether you think about, when you look at these two graphs, the only thing that's, this high demand in theory is this high demand. These two are the same. The only thing we've done is we've flipped the supply curve. And so that's kind of what we're doing here, is this is the supply curve here, here's isolation. So if we drew the supply curve in each one, isolation sitting here, that's that situation. Here's the cluster. Let's compare the two. And so I'm just kind of picking off the results and looking at what the benefit is. And it's the benefit to the firm because it's the demand curve. They're the ones buying the labor, so they're picking up that area. Okay, anything else? So we do the similar thing for the bad times. So during bad times, the cost of being in the cluster as opposed to being isolated is what? So now we're going to take the low demand curve, and we're either in this situation, which is here at 30 and 40, or we're here at 30 and, oh, this is 20 actually. That's a typo. A righto, yes. At 20. And so then again, that shaded area is the difference, to answer that question. So it works against you in this one. Go ahead.
I was just going to say on the test, if you were asking a question like this, you'd probably ask maybe similar, maybe the numbers would be different, and display different. The idea was
Unless it's the challenge question.
What's the likelihood you'll ask?
No, it probably wouldn't. I wouldn't. On this particular one, right? It's going to, yeah.
challenge question.
So change some numbers around.
That's right. Yeah.
If you want me to help you lower your test anxiety, I'll maybe change some numbers in the table around. And you
What's
gotta
the
explain.
likelihood you'll
Cannot, no comment.
I mean, you haven't written it, so you can't tell us what's on the test.
That's true.
You're just speculating at this point. So what's, right?
No comment. I refuse.
Can that be what we
I
get
do
from
reserve
going
the
on?
right to hold back.
I already have to do that with one class. And I think I'm after it.
You and math stats?
Let's see, the benefit seats
I
gone.
hear that class
Okay.
sucks, that's why.
Anything else on that one?
That sucks. I really think you
Well,
should tell us now.
for D, just the benefit exceeded the cost because the firm and cluster gets.
Oh, my son got a ride. Okay. That means I will not take points away from you, like Katie being illegal right now as we speak. Okay.
I think we're all.
I know, that's what I just said. I said you guys don't get a point, but I don't take away a point either. So you can have yourself a point.
Well, you've had 2.
Yeah, well, my son is at violin practice, so I asked him to go find a ride home so that I could be with you guys instead of my son tonight.
Wow. He's talking with Alice Joy. It's the one and only.
Appreciate it.
So,
Did you answer D?
D, because the clustered firm changes its workforce when the demand changes. So the answer, the benefit exceeds the cost, and this was, I might have paraphrased a little bit from your answer key, but because a clustered firm changes its workforce when the demand changes. Okay, let's see, what else in chapter 3 was number 7?
Yeah.
Number 7, we got some advertisers. Okay, using a graph like 3-2, show the profit gap in the cluster. Okay, so if I remember right, the person who sent this in said something about the gap. I can't remember who sent it in for sure, but
Oh, this one. Oh yeah, it's the one that I.
did you send it in?
No, but I drew these painstakingly out.
Okay. Yeah, so you could draw a nice little graph, which I didn't do, but would be one way to try to do it. But the idea here is they gave you a function of advertising cost going down. So the intuition would be that if you've got more firms there, the advertiser can offer you a better deal. And by the way, this really does work in the real world. If advertisers are in a bigger area, bigger industry, then they could probably offer some stuff at lower cost than what they could otherwise on imagine I've purchased these little the placemats at the restaurants and the number of advertisers that are there, right? If there's more advertisers, they might be able to alter the cost a little bit. So as the number of firms increase, we have some savings in advertising costs. Labor cost is going up at a linear rate, right? This one's going up 120 to 60, 60 to 40, 40 to 10. We got that diminishing rate, so if we were graphing that out, it'd be kind of going up at a declining rate. We've got this going up at a linear rate, so the two are going to collide with each other at some point. And so our total cost, adding those two together looks like that. They kept the revenues constant for simplicity. Again, this is the number of firms, so I guess they're all price takers maybe. And then we calculate the profit. So if we're all by ourselves, the profit is 50. And if we start to get a couple firms together, we are able to take advantage of the advertising, which gives us a profit gap of 30. And now, should I stay solo, or should I, add in another, or get another firm in? As long as there's profits that are higher, again, it's 70 versus 50, so the gap is positive.
So the profit gap is always from the isolated firm?
Yes.
Okay.
Yep. Yeah, the gap is from the isolated firm. So the two firms together earn a profit of 80, which is 30 greater than in isolation. And so that was the gap part. And then we're going to keep adding firms until we're indifferent between
that makes sense.
being in a cluster versus being solo. Okay, anything else on that one? All right, I think that was all. Any other questions on 3 as you're eyeballing it?
Yeah.
Okay, chapter 4. So 4 and 5 kind of went together. 4 was kind of the first step into doing the problems.
Over or grass or just kind of like wage.
So, chapter 4, city size. So we got this little utility hill here, and we're measuring the number of workers in the city. So how big will the city get? What was the two competing forces that gave this look?
Utility for urbanization and just utility from pollution.
From congestion and pollution, right? So those were our two competing forces. As we start to get more and more people, we enjoy increase in wages, right? So wages were going up, which was part of it. So we had wages climbing, but then we've got congestion. And we got both of that going on here. So we've got increase in wages and increase in congestion. These were our competing forces on utility. And so then we thought which would be stable when we started thinking about migration between cities. And this might be my tapping into chapter, actually we didn't do that, that's chapter 5 that we start thinking about migration between the two cities, I think. Is that right?
There's 4, we migrate from 4 to equal utility points.
I did like migration and innovation stuff.
Yep.
Then we start shifting it. So the size of the city depending on urbanization.
Page 78, Russ, at the bottom.
That was literally the entire homework you saw in those.
Yeah, was doing the utility.
And like how many workers in the city.
So as long as you study pages 78 to 82, do we go in this chapter, right?
Basically.
Yeah.
There's lots of fun little graphs in the PowerPoint. but-
Cities may be too large, but not too small.
They can always have positive increases in utilities.
Right.
It matters. Wait, what?
So, yeah, the question that was being answered here wasn't, I think the migration story was still from chapter 5, but here city size increases will be okay. That's the self-reinforcing part. So, if we're on the positive slope, city grows. We have the self-reinforcing. We've got the benefits outweighing the costs. As soon as we get here, congestion starts to overwhelm it. And in the negative slope, we are actually stable. There's no incentive for people to continue to come in if they've got other alternatives.
Due to congestion.
The congestion effect outweighing the increase in wages. an extra person. Remember, the people are homogeneous in this thing, so an extra person sees utility fall. All right, and then we had the rank size rule was the other thing at the end. So we had the rank size rule, and that was the graph that we kind of observed. City size, rank, the biggest city, the second, the third, the fourth tends to look like that, which they found approximates this little rule of thumb. The population of city I is approximately equal to the population of city 1 divided by the rank of city I. So it's, okay, see you later.
Well,
Oh, what'd you say?
When will you have it posted?
Probably not till tomorrow. We don't have too much more to go, but yeah. So if the biggest city has 50 million people, the second biggest city, 50 divided by 2 is 25. That's why we got this hockey stick look, is that we start with 50, the second city has 25. So that's what this thing is kind of approximating. The city with rank I, the second largest city, take the biggest city divided by the rank. That was the concept. That was the concept.
Will there be much on that, do you think?
Whatever our problems were. So, and then it was really kind of an observation that approximates that rule, and then there was some studies that said how closely is it to that little, it's kind of a rule of thumb. But do you get this part, Kate?
Yeah.
So if the biggest city is 50 million, the second biggest city is 25. The third biggest city is 33. You know, and we just kind of 17. 50 thirds. 50 divided by 3. So that keep going down that way. That's an easy way out of skipping the math in my
And
head.
the rank is important just because,
It was more of an empirical observation of how cities form. And so we've got concentration, the agglomerations, localization and urbanization causes these big cities to form. And then why would they look different on the outskirts? And so it's kind of an observation. All right. And then chapter 5, well, let's see, chapter 4. Number 5. So, new cities, boom or bust. Consider a region with 12 million people in a single city. The urban utility curve reaches a max at 6 million and includes this combination. So 6, it's at 55 units of utility. Suppose the government splits it up with 1 million in one city and 11 million in another city. You got it?
This was the one that we went over in class, then I didn't.
Oh, is this not the one you wanted? Oh.
Oh, I didn't.
I don't know if
That
you
was the
did
one
this one or
I-
not.
No,
Oh,
I
okay.
was-
So, immediately following the establishment of the new city, the utility in the small city is how much? So we just have 1 million in the one city, so what's the utility according to that schedule? 23. And in the other city, there's 11 million people at 30. So, what's going to happen to the new city? Shrink. So, people are looking at that saying, oh man, the old city's at 30, I'm sitting here at 23, screw this, I'm out of here. And so, as they leave that city, they go over to the new one, and the new city disappears. In the long run, it would be gone. Yeah.
The new cities.
The new city.
That's weird.
Right, and that's just by the,
Why did it even form?
well, the government,
This is like
this is actually a perfect example. The government decided that it would be a good idea to start a city instead of the market deciding to start a city. And so when the government decides to start a city, you put one, they didn't,
Well, it's like connecting dots here, 'cause we lost for a
so
while.
yes, it's gone. Now,
This is beautiful.
but part C resurrects the city fathers here in their planning. A new city would be viable if the starting workforce is at least, where did we need to be on the population? So it turned out to be 3, I think. Is that right?
Yeah, it was 3.
So now let's look at the numbers. So if we're at 3 with the new city, that means we got to be at 9 with the old city, right? Because there's only a grand total of 12.
Oh.
And now look at what's going on. We've got the old city at 40 units of utility, the new city at 43. And so what's going to happen now?
People are going to leave the old city and come to these.
Leave the old, go to the new, because it's a happier place to be at 43. And so then the new city now has 4 million at 48, the old city's at 45. That continues again, right? And so they're going to keep migrating until we get to 2 cities of 6 million.
Did you say B was 12 million, Russ?
Yes.
I thought this was the one that went over down in their office, that was like super complicated. That's what
Oh,
I
that
saw
one.
it in my answers, I was like, oh, but it was.
Oh, so they all go old.
Yeah, so like in the long
So it won't be split.
Wait, so, answer to B was, answer A was the new city will shrink and the old city will grow.
Right.
Yeah.
The new city's going to disappear. Yeah.
That's based on these numbers, though. You could flip that on the test, correct?
Yes. Yeah, so it's important to look at the numbers. So is everybody clear on what happened with the numbers there? I mean, it depends on which utility's higher, how things might
It's good to
change.
point that out, though, because I could study this way and go, oh, that's weird.
Yeah, we're trying to get to that deeper level of understanding. Okay, any other ones on chapter 4?
Oh, yeah, every time.
In chapter 5, we kind of covered today.
We do the appendix in chapter 4, Russ?
Yes, that was the central place
There's a
stuff.
slide.
It was kind of a quick thing, but yeah, you guys have the slides on it where the
FYI.
big city. Yeah, that one. Okay, so chapter 5, that's where we got into the migration stuff and shifting
On
up.
that left email, you sent me connected 2 through 5 PowerPoints, correct?
It's even 1 through 5. Yeah, chapter 1 was on there. There's a few things on the axioms. So chapter 1 through 5.
You're gonna have to delete some animations
Oh,
so they will read it better.
Oh, is that? Oh, you mean to just see what's underneath?
Yes.
You can also move them. If you grab onto the those little boxes that I do for presentation purposes, you can just get those out of the way.
Oh, is that the book, or is that you doing that?
That's him.
That's me.
That's
If you would-
fair.
If you would send the ones that were, that did not say Russ on them, we would not have.
Yeah, I could do that. A few of them. I threw out some of them, but if you want the raw PowerPoints, I thought so. You guys don't. I couldn't remember if you guys have access to those on your student resources. with the-
Is it the website?
Yeah, it might be, but I can email them to
That'd
you
be
too.
nice to know that we had that.
International.
It would be good to, do we have that for international too?
Yeah, international. they're on there, yeah.
International definitely doesn't.
Yeah.
What? Where's that website?
So yeah, you guys can. If one of you emails me, I'll clip
What?
those on and send
I
the
was thinking
raw ones.
international economics.
You're on camera, by the way.
You gotta be kidding me.
Okie doke.
Yeah, I know, that's why I stopped.
All right, are we good for tonight, folks?
What?
Yes.
Russ, what did you say? How successful?
Oh yeah, you weren't here.
We did that in class, so,
Yeah.
so we're not doing Econ.
Basically, if you go through all these problems and you understand them pretty well, and you've kind of worked them and you understand the logic, you'll probably see you will see some problems where the numbers are basically changed. So that if you know the logic of them and you did your homework, then that'll be the large part of the exam. And then I will have some problems that'll be maybe kind of new or different that might be outside of that.
Did you use any multiple choices?
I haven't written it yet, but no, I'm not really.
I was gonna say, this is more like.
It's probably going to be more problems and short answers.